Hello, mentors. Let's take a detailed look at how these dynamics in the hexagonal grid work. So this is part 2 of meeting 5, and we're in simulations, and in particular, we are in these explorations. So both play together and explorations, actually, in which they need to understand students how we move if we are unhappy, right? If a shape is unhappy. So here's the rules. I am unhappy if and only if more than 52% or 70% of my neighbors are unlike me, so different shape. And if I have 0 neighbors, I am just unhappy. We'll have this as a rule so that we try to not have isolated shapes. For example, for 52%, if students want to play with this parameter in the simulation, a shape moves if more than 52% of their neighbors look unlike that shape. For example, if you had a square and it's surrounded by 2 squares and 4 triangles, it has a bunch of triangles, 4 out of 6, right, for neighbors, so 66.6, and that's larger than 52, so this shape would be unhappy. Notice the delicate balance, because if they chose 70%, then the shape would actually be totally happy. It would be a more tolerant society or a more tolerant system. Let's look at these 9 examples here to understand it. Let's do it with 70%, which is a bit more involved than the 52%. And the reason we pick 52% is so that it's easier for situations where you have exactly half and half as far as neighbors that are like and alike. So 52 is just easier to remember which decision to make. So it's just cosmetics. 70% is also good because you'll never fall into exactly 70% with these fractions that we'll see. Okay, so in all these examples, we're looking at this center shape in the hexagon grid, and we have a bunch of neighbors, and we're trying to, help this shape decide if they're happy or unhappy, and if they're gonna move or not, right? So, sorry, let me just delete this here for this first example. In this first case, there's nothing unlike me, right? I don't see any red shapes, but I have no neighbors. I have 0 neighbors, so I'll move. I'm unhappy just by the definition of the problem. It's just a rule, this part of the rule. So I'm unhappy. Here we have 1 neighbor, and it's so 0 out of 1 are unlike me. So 0% problems somehow. So happy. Here I have 2 neighbors. We are in a 50% situation. I'm quite happy because this doesn't go past the 70%. So I'm pretty tolerant, and I can live with 1 neighbor of red, 1 neighbor of green. Same would happen in the 52%. Notice just barely, right? So it's kind of almost borderline, but it would also be happy in the 52%. Here I have 3 neighbors. And what's interesting is that intuitively you would say it's not happy, but technically in this model, since the tolerance level is so high, 70%, it's actually happy. So it can live with the fact that 1 out of 3 are like him, because 66.6 are not like him, and that's low. It's smaller than 70%. So it's happy. With 4 neighbors, 2 and 2, half and half, quite happy, it's fine. But now if 3 out of the 4 neighbors were to be different color or different shape, then that bumps to 75%, and then the model says, nope, now you are happy, you have to move. So this would need to move. So in this case, I think it's interesting and important when you have 3 out of 4. Now with 5 neighbors, again, if you have 3 out of 5, that's 60%, you're happy, you can tolerate it, you're not gonna move. And then in the case where all these spaces, all these hexagons are filled with neighbors, so you have 6 neighbors, even if you have 4 that are not like you would be happy. And only if you have 5 or 6 that are not like you, that bumps to 83.3%, then you're unhappy and you will move. So as you can see, there's lots of happiness here, and it's kind of difficult to move. In this case, we have to be either isolated or 3 out of 4, not like you, or 5 out of 6, not like you. Actually, 4 out of 5, it's not in the picture, but that would also be a case where you would move because 4 out of 5 is 80%. So we didn't put it in these examples, but it would also be a case of being unhappy. And there's some other few cases, such as 2 out of 2 here, and etc. Now, how did this work? Well, students should figure out these rules, and then it's about how they, how they keep track of them. Maybe they draw a table, a little diagram. Maybe they just work so well mentally that they don't have to keep track. But it's also part of the math and the math modeling and the representations, how they're gonna keep track of this and be efficient. So it's a skill. How are you gonna be able to efficiently move around and don't repeat this calculation every single time? So make sure you take this into account when planning the meeting to anticipate for that, and see you in the next video. Goodbye.